Okay, no cat hat today, but I'm starting again with naming of compounds and formula writing. We did binary ionic, where we had two things with the plus and the minus yesterday. Today we're doing polyatomic ions, looking at binary molecular, which are the di, tri, tetra ones, and looking at a short list of acids you have to know. Tomorrow, we're going to go over the entire practice at the back of the packet and do it together. So, let's start with these. For polyatomic ions, that's when there's more than two capital letters in the compound, you get those groups. I listed a few in the packet, and you're going to get a shortened ion sheet, not the monster we had in class, one with 10 or less of them on it to use. So, I've got ammonium, NH4+. That means that together, it has a +1 charge. OH-, those together have a -1 charge. When we use them, and we need more than one of them, we have to put them in parentheses to show that. So follow along on that list. If you've got your periodic table marked with your charges, get that out too. So I've got NaOH. Too many capital letters. It's got 3. Usually this first thing is separate, unless it's NH4. Li2, yup. Oh, that's nice. There's parentheses there. And Al, I know Al, that's aluminum. That's how I split up the names. I name what's before and I name what's after. Na, sodium. Look on my list for OH, there it is. Hydroxide, easy. Li, lithium. And look up CO3, carbonate. We had a few of you guys in class making up some creative names for those, like lithium carbonoxygenide. Don't try that hard. If there are more than 2 capital letters, check your polyatomic ion sheet, because something's coming from there. You don't need to make up names. You need to use your ion sheet for 3 or more capital letters. This one's even better. There's parentheses. We're going to name what's in the parentheses. Mg, magnesium. NO3, nitrate. What's that 2 doing? That 2 is there to cancel my charge. Magnesium's +2, nitrate's -1. That's where that came from. And alpo, yes, it's dog food, but here it's aluminum. And that ion is phosphate, aluminum phosphate. So those are your namings. Let's do some writings. We've got, we're going to do calcium sulfate. Calcium is +2. Sulfate, ATE ending. So I'm going to my ion sheet and I'm checking for it. Sulfate's -2. +2 and -2, I'm just writing them. CaSO4. Done. Lithium. We just did lithium. It's +1. It's in group 1. That's how I know that. And phosphate was PO4. -3. It's on my list. Just like always, I'm crossing my charges. I need 3 lithiums and 1 phosphate, Li3PO4. Beryllium hydroxide, beryllium group 2, so +2. Hydroxide, -1. Why do I know that? Hydroxide's on my polyatomic ion list. Very good. BeOH, so I want 1 beryllium, and I want 2 OHs. But I can't just do that, because that just says 2 H's. I need parentheses. Ammonium nitrate. Ooh, ammonium. The only polyatomic cation we need. Where is it on my periodic table? It's not on my periodic table unless you wrote it there. NH4 is +1. NO3 is -1. Equal but opposite, I'm done. Ammonium nitrate. Quick review. That's when you need parentheses, when you have more than one of a polyatomic ion. Your next review, let me scroll down, is of binary molecular compounds, which are the ones that are over here. I scribbled them in over there in pink. When you get 2 things from that side of the periodic table, you're looking to use these prefixes. I've got the prefixes in your packet, so please review those. Remember, most of them make sense except tetra for 4. And the other, remember, is that the subscript, the little number at the bottom, its prefix goes on that element. So let's look at our first one, BF3. One of the first one, we don't do anything. We just name it boron. That was a 3-legged dinosaur in my room. He's waiting for us. F for fluorine, but we've got a 3. So 3 is tri, and then we write fluoride. This is what I mean. Because there's 3 borons, tri goes there. What do I got next? P2O5. 2 is di. We don't change our first ending. Diphosphorus. Not phosphide. Diphosphorus. We got 5 in the next one. Pent. Oxide. Diphosphorus pentoxide. Next one, NO2. That's just nitrogen. 2 of them. Dioxide. And CO should be easy. That's one of the compounds you first talk about. Carbon. Don't need mono because it's first, but for the second one I do. Mon. Oxide. Carbon monoxide. Not too bad. Now when we're given the formulas, or we're given the names, we can write the formulas too. And don't worry, we're going to practice these tomorrow, or I don't know if it's a Monday lecture, we'll see. Next time I see you, we practice these. Oxygen difluoride. Okay, oxygen and fluorine. Must only be one oxygen, no prefix. Difluoride says 2. Tetraphosphorus. Like Tetris, it's 4. And decaoxide. Deca is 10. The prefixes tell you how many of that thing. Carbon. Tetrachloride. So I have 4 chlorines. Tetrachloride, all one word. They all go together. And dinitrogen. Monoxide. Only rules, don't use mono with the first one, and the prefix tells you how many of that thing. We had 8 acids to memorize when we did these in class. Acids always start with hydrogen. We have 2 binary acids to learn, hydrochloric HCl, hydrobromic HBr, and 2 oxyacids to learn, HNO3 nitric acid and H2SO4 sulfuric acid. The next page of this packet should be a review and a mini ion sheet for you. Yep. We are going to do these together. Well, I'm going to work on them for the next lecture. You can try them now. You can do them then. You can pause midway through. But this is your practice. And if you want to try ahead of time, go for it. See you next time.